welcome back. And for this video, we are going to talk about topic 7.1, the last part of it, our part 3, very short video, where we will discuss on the formal charge and also we will discuss on the plausible Lewis structure. What is formal charge and what is plausible Lewis structure? So, what is actually formal charge? Formal charge is the charge assigned to each of the atom in a molecule. For a very simple example like H2O. In your H2O, hydrogen actually holding a charge. Oxygen actually holding a charge. This hydrogen also actually holding the charge. What is their charge? That is what we call formal charge. And the formula to calculate the formal charge is this. Formal charge equals to the number of valence electron of the atom minus the non-bonding electron at the atom minus the number of bonding around the atom. Don't worry, we'll look into that later on. And a bit of tips for you for formal charge. The total formal charge calculated must equal to the charge of the molecule. If your molecule is neutral, the total formal charge need to be 0. If the molecule is a -1, then your total formal charge need to be -1. Don't worry, we'll look into some example later on. So, what is the function of this formal charge? The function of the formal charge is actually used to determine the most plausible structure. So, the question over here again, what is plausible, right? So we say that the function of formal charge is used to determine the most plausible structure. But what is plausible structure? Plausible Lewis structure is actually like the most stable Lewis structure. You might have more than one Lewis structure for a molecule. So we are going to choose the most stable Lewis structure. And how can we choose the most stable Lewis structure? The plausible Lewis structure must have the most zero formal charge. When you calculate your formal charge, we will choose the molecule that have most atom with 0 formal charge, or the atom that have the lowest possible formal charge. Or we are going to choose when the negative charge is at the most electronegative atom. So there is a few ways to choose the most stable Lewis structure or the most plausible Lewis structure, but most of the time we'll look at the most 0 formal charge. Okay? In the other words, most 0 also the lowest. We are looking for the lowest possible formal charge. And how can we determine the most plausible Lewis structure? There is a few steps, very simple step. First and foremost, draw all possible Lewis structure. Alright, you're going to draw all structure that obey the octet rule and obey the Lewis structure rules. We are going to draw all the possible structure. And then you are going to calculate the formal charge for each of the atom. Because formal charge is the only way to determine the most plausible structure. After you calculate the formal charge for each atom, we are going to compare it and we are going to choose the structure that have the lowest possible formal charge. And the one with most 0 formal charge will be the most plausible structure. Simple, there is only 3 steps, but make sure you know how to draw all the possible Lewis structure correctly. Let's look at our first example, CO2. The step 1 is of course to draw the all possible Lewis structure. So we are going to draw all the possible Lewis structure by calculating the total valence electron first. The total valence electron for carbon dioxide, carbon 4, oxygen 6 times 2, 12. So the total valence electron 16. I start off with the Lewis structure, C single bond O, the skeletal structure. Minus 4 electron over here because of the 2 single bond. So you left 12 electron. And the next step is to octet all your terminal atom. So we are going to octet all your terminal atom. Your oxygen need another 6 electron to achieve octet. So make it octet. And right now, you have put in all your 12 electron and your total valence electron goes to 0. Next, we check whether it's octet or not. You realize that your oxygen right now is octet, your oxygen right now is octet, but your carbon right now is not octet. Bear that in mind, carbon must achieve octet no matter where they are. So how can I make carbon octet? There is a few ways to make carbon octet. That's why we have a few possible Lewis structure. The first method is both of the oxygen donated a lone pair. Alright, so the oxygen give in a lone pair, the oxygen give in a lone pair, where you will form the first possible Lewis structure, which is this. You form a double bond, and then every oxygen will only left with 2 lone pair, because one of the lone pair is donated and to form a double bond. And right now you realize that, alright, both of the oxygen remain octet. Your carbon right now also octet. With the 4 single bond times 2, you have 8 electron around the carbon. So this is the first possible structure of CO2. We can have another possible structure where both of the lone pair is donated by the same oxygen. In the other words, this oxygen doesn't donate this lone pair, but this oxygen on the right donated 2 lone pair. So your structure will look something like this. On the left-hand side, oxygen will remain the same. Okay, with the single bond to the carbon. But on the right-hand side, the carbon form a triple bond with the oxygen, and the oxygen will only left with 1 lone pair because both lone pair donated to form a bond so that the carbon can be octet. Don't worry about the oxygen. You realize that the oxygen still remain octet. Okay, you have 2 electrons over here with the 3 single bond. And every single bond is having 2 electrons. So the oxygen remain octet. The oxygen over here also remain octet. So this is the second possible structure that I can have for my CO2. I have 2 possible structure over here. Which one will be the most plausible? We then need to calculate the former charge. So we are going to calculate the former charge by using this formula above. So let's see how it works. For the oxygen in your structure 1, the oxygen having 6 valence electron minus the non-bonding electron. How many non-bonding electron we have? We have 4 non-bonding electron. Non-bonding electron is actually your lone pair. Alright, so minus 4 over here, and then minus the number of bonding. We have 2 bonding over here, so we are going to minus 2. So 6 minus 4 minus 2, oxygen will be holding a charge of 0. Both oxygen are the same over here. If you realize both of this oxygen is the same, 6 minus 4 minus 2. So both oxygen is 0. Your carbon in your structure 1 will be valence electron 4 minus non-bonding electron 0 because there is no lone pair around this carbon. So non-bonding electron is 0 minus number of bonding. So number of bonding around carbon is 4. I have 4 bond over here minus 4. 4 minus 0 minus 4, 0. So the former charge assigned to each atom in this structure, oxygen is 0, carbon is 0, this oxygen also 0. Okay, that is the former charge. While for the second structure, the oxygen, we have 2 different oxygens, so we need to calculate the former charge for both oxygen. So oxygen with the single bond will equals to valence electron 6, alright, number of valence electron, minus the non-bonding electron over here is 6, minus 6, minus number of bonding. So this oxygen having 1 bond, minus 1. So 6 minus 6 minus 1, you will then have negative 1 for this oxygen. So the former charge of this oxygen will be negative 1, calculated over here. Let's calculate the former charge of carbon. So carbon over here, valence electron of carbon 4 minus non-bonding electron. There is no non-bonding electron around the carbon. There is no lone pair. So 0 minus number of bonding. How many bonding is there in the carbon? Around the carbon, there is 1 single bond, 3 triple bond. So minus 4. So carbon again is 0 in this structure. So the former charge of carbon in here is 0. Next, let's calculate the triple bond oxygen. So the triple bond oxygen over here, again, valence electron of oxygen 6 minus the non-bonding electron. The non-bonding electron over here, 2. So 6 minus 2 minus the number of bonding. I have 1 bonding, 2 bonding, 3 bonding. So we minus 3. 6 minus 2 minus 3, I will have positive 1. So the formal charge of the triple bond oxygen will be positive 1 as calculated. And before we proceed to determine the most plausible structure, like I said previously, the total formal charge must equal to the total charge of the molecule. Your molecule right now is neutral. There is no charge. So the formal charge total must also be neutral. You have 0, plus 0, plus 0. So for this one, is correct. 0 plus 0, total of this is 0. You have negative 1 over here for this oxygen. You have 0 over here. You have positive 1. So negative 1 plus 0 plus positive 1, back to 0. So one of the way to determine whether your formal charge is correct or wrong is add all your formal charge up, and the total of your formal charge must equal to the charge of your molecule. That is one of the methods. And in these two structures, your structure 1 and structure 2, which one do you think is the most plausible? According to what we have learned just now, the most plausible structure must be the one that with most 0. Over here, I have 0, 0, 0. Over here, I have negative 1, 0, positive 1. Obviously, structure 1 will be the most plausible because it has most 0 formal charge. So this is the way to determine the most plausible Lewis structure. Let's try another example. The second example that I have on the screen is POCl3. First and foremost, we are going to draw all possible Lewis structure, and we always start with total valence electron. So the total valence electron is 32 electron. And in your POCl3, your phosphorus is the least electron negative, therefore your phosphorus will be the central atom. So your phosphorus will be the central atom, bonded single bond to the chlorine, and also single bond to the oxygen. Therefore, you minus 8, and you have 24 electron left. And as always, according to Lewis structure, we need to octet all your terminal atom. So we octet all the terminal atom by making it 8 valence electron. So they're already having a bonding with 2 electrons. So every one deserves to have another 6 electrons to make them octet. After you octet all your terminal atom, they already used up all the 24 electrons. Therefore, your total valence electron now is 0. And then we check the octet of this Lewis structure. You realize that everything in here is octet. Your oxygen is octet. Your chlorine is octet. And also your phosphorus also octet with 8 electrons around it. If this is already the correct Lewis structure, why do I need to calculate the formal charge? Because you can have another Lewis structure. Bear that in mind, your phosphorus is in a period 3. So your phosphorus can be expanded octet. Expanded octet means your phosphorus can have more than 8 electrons around it. How can phosphorus have more than 8 electrons around it? Simple. Oxygen giving the lone pair forming double bond with the phosphorus. So you can have another possible Lewis structure where your phosphorus remain in the central. All the chlorine remain unchanged with their lone pair, but the oxygen changes. The oxygen will form a double bond with the phosphorus. Therefore, the oxygen donated one of the lone pair, and now the oxygen only have 2 lone pair left. So this is the another possible Lewis structure. Therefore, that is my structure 1, and this is my structure 2. And next, what do? We need to calculate the formal charge. So we are going to calculate the formal charge for each and every one of them. But you realize that all the chlorine are the same. So you don't calculate 3 times. You only calculate 1 time. Calculate for the chlorine first. The chlorine valence electron is 7. Minus the non-bonding electron. How many non-bonding electron we are having? So we are having 3 lone pair. Every lone pair is 2 electron. So we have 2, 2, 2. Total 6 non-bonding electron. Minus number of bonding. How many bonding the chlorine having? 1. So minus 1. So chlorine over here will be 7 minus 6 minus 1, 0. Therefore, chlorine, every single chlorine over here will be holding a 0 formal charge. Next, let's calculate for oxygen. Oxygen, valence electron 6 minus non-bonding electron. Non-bonding electron for my oxygen in my structure 1 is 2, 4, 6 minus 6 minus the number of bonding. Number of bonding in this oxygen is 1. So minus 1 equals to 6 minus 6 minus 1, you will have negative 1. So my oxygen over here will be negative 1 formal charge. Last but not least, let's calculate for phosphorus. Phosphorus, valence electron 5 minus non-bonding electron. There is no non-bonding electron around the phosphorus. So minus 0 minus number of bonding. Phosphorus having 4 bonding around it. Therefore, minus 4. 5 minus 0 minus 4, positive 1. So phosphorus will be positive 1 in this structure. And you can see over here, when you have 0, plus 0, plus 0, plus positive 1, plus negative 1. Total is 0. So POCl3 is a neutral compound. It's a neutral molecule. So all the total formal charge must back to 0. So my formal charge right now is correct. Let's calculate for my structure 2. Same thing. All the chlorine over here is the same. So we only calculate one time. Your chlorine over here, valence electron 7 minus non-bonding electron. I have 6 non-bonding electron. Minus 1 bond, number of bond, minus 1. So the chlorine over here again 0. So all the chlorine over here, we're having a formal charge 0. Next, we calculate for oxygen. Oxygen valence electron 6 minus non-bonding electron. I have 4 non-bonding electron, 2 plus 2, 6 minus 4 minus number of bonding. I have 2 bond. I have a double bond over here. So I minus 2. So 6 minus 4 minus 2, I have 0. So your oxygen in your structure 2 will hold a 0 formal charge. Last but not least, let's calculate for phosphorus. Phosphorus over here is 5. 5 minus non-bonding electron. There is no non-bonding electron. Minus 0. Minus number of bonding. How many bond around the phosphorus? 1, 2, 3, 4, 5. So minus 5 equals to 0. So the phosphorus calculated over here in your structure 2 also 0. And like we say, POCl3 is a neutral, so the total of the formal charge must equals to 0. 0 plus 0, everything is 0. And according to the rules that we have learned, which one is the most plausible structure? In your structure 1, you have your negative 1, positive 1. In your structure 2, everything is 0. So who is more plausible? Of course, your structure 2. So your structure 2 is the most plausible structure, or in the other words, is the most stable structure because it has most 0 formal charge in the Lewis structure. Simple, very simple. So let's go to the last example. What happened when you have charge OCN minus? It's a OCN minus, you have a negative charge over here. So the total formal charge must equals to negative 1 because we have a OCN minus. So let's start with the total valence electron. Valence electron of oxygen 6, valence electron of carbon 4, valence electron of nitrogen 5. So the total over here is 15. But don't forget the charge. I have a negative charge over here. Since the charge is negative 1, negative means we are accepting electron. So we have extra electron over here. Plus 1, I have 16 electron in total. What would be the possible Lewis structure? How many possible Lewis structure are we having? First and foremost, let's start with the skeletal structure where the arrangement would be O, C, N. Don't forget the charge, so you put a bracket with the charge. So you have OCN minus with 2 single bond. So 16 electron minus 4 electron. You have 12 electron left. So the 12 electron, we need to octet all your terminal atom. So your terminal atom is your oxygen and nitrogen. Make it octet. So we have used up all the 12 electron to make your oxygen and nitrogen octet. So that is your Lewis structure at this moment. But you realize that your carbon over here is not octet. But we know that carbon must achieve octet no matter what. So the question over here is, how can carbon achieve octet at this moment? Simple. There is 3 ways, which means I can have 3 possible Lewis structure. Let's see. The first one is taking the lone pair from the oxygen, bringing it into the carbon, and taking 1 from the nitrogen, bringing it to the carbon. So the first structure will look something like this. Oxygen left with 2 lone pair, forming double bond with the carbon, carbon forming double bond with the nitrogen, and nitrogen left with 2 lone pair as well, because one of the lone pair donated to form a double bond with carbon. Don't forget the charge. And that is my structure 1. What would be my structure 2? How should the structure 2 look like? Your structure 2 can be both lone pair donated by the oxygen. So oxygen giving in 2 lone pair to the carbon, and nitrogen do nothing in this case. So how would the Lewis structure look like? The Lewis structure will look something like this. The oxygen right now forming triple bond with the carbon, and oxygen will only left 1 lone pair because 2 of the lone pair already forming a bond. And your nitrogen do nothing, therefore your nitrogen remain with the 3 lone pair. And don't forget the charge, bracket, charge. That is my second structure. What do you think my third structure look like? Vice versa with the second structure, both of the lone pair will be donated by the nitrogen. Both of the lone pair is given out by the nitrogen. So in this structure, oxygen is the one that do nothing. So oxygen will remain unchanged with the 3 lone pair and also the single bond to the carbon. While the nitrogen donated 2 lone pair, so nitrogen will be forming triple bond with the carbon and left with only 1 lone pair. And again, don't forget the charge. So I have my -1 over here. So this is all my possible structure. Structure 1, structure 2, structure 3. Next, you need to find who is the most plausible. We need to find who is the most plausible by calculating the former charge. So first and foremost, let's calculate the former charge of oxygen in my structure 1. Oxygen in my structure 1 is 6 valence electron minus 4 non-bonding electron minus 2 bonding. So oxygen in this case is 0. Next, carbon in this case, carbon valence electron 4 minus non-bonding electron, there is no lone pair, so 0, minus number of bond, carbon holding 4 bond, so minus 4, carbon equals to 0. So carbon is 0 over here. While nitrogen, valence electron 5, minus non-bonding electron 1, 2, 3, 4, minus 4, minus number of bond having 2, 1, 2, minus 2. So nitrogen now is 5 minus 4 minus 2, -1. So your nitrogen calculated in your structure 1 is -1. Like we have mentioned just now, your total charge is -1. When all your former charge added up, your former charge must equals to -1. 0 plus 0 plus -1. Simple. So let's look at structure 2. What would be the former charge of oxygen in structure 2? Oxygen in structure 2 will be 6 valence electron minus non-bonding electron. I have 2 non-bonding electron minus 2 minus number of bond. I have 3 bond over here. 1, 2, 3 minus 3. So oxygen will be +1 in this case. Oxygen +1. Carbon in this structure, carbon will be 4 minus 0 minus 4. Non-bonding electron is 0, number of bond is 4. Therefore, carbon again is 0. Carbon remains 0 in structure 2. How about nitrogen? Nitrogen will be 5 valence electron minus non-bonding electron. I have 6 non-bonding electron minus 6 minus number of bonding 1 minus 1. So 5 minus 6 minus 1 over here is negative 2. So your nitrogen in structure 2, the former charge is negative 2. Like we have agreed, the total former charge must equals to the charge of the molecule. The charge of the molecule is negative 1. Your total former charge also negative 1. So your former charge correct. Last but not least, structure 3. So calculate the former charge of oxygen in structure 3. You have valence electron 6 minus non-bonding electron 6 over here, minus number of bonding 1. So you have 6 minus 6 minus 1. You have negative 1 oxygen over here. So your oxygen calculated negative 1. Carbon, valence electron 4 minus non-bonding electron 0 minus number of bond 4. Therefore, carbon is 0. Carbon again remains 0 in your structure 3. Last but not least, nitrogen in your structure 3. Your nitrogen over here will be valence electron 5 minus non-bonding electron 2 minus number of bond 3. So nitrogen over here remain 0. And again, we check our former charge. The addition of the former charge must total back to the charge of the molecule. Negative 1 plus 0 equals to negative 1. And over here, you have 3 structures, structure 1, structure 2, and structure 3. The question over here, who is the most plausible? What do you think? Your structure 2 is definitely out. The first structure that out is structure 2. Why? Because you have negative 2 charge in there. And you can see in your structure 1 and structure 3, we only have 0, 0, negative 1, 0, 0, negative 1. So structure 2 definitely out. But in between structure 1 and structure 3, who is the most plausible? Look at the negative charge. In structure 1, the negative charge is located in the nitrogen. In structure 3, the negative charge is located in the oxygen. So who should be holding the negative charge? The most plausible structure is 3. Why? Because oxygen is more electronegative than nitrogen. So when oxygen is more electronegative than nitrogen, the negative charge will be on oxygen is more stable than in nitrogen. So our most plausible structure for this case is your structure 3. And that is all about former charge and the plausible structure. Bear that in mind, whenever question asking for plausible structure, you must calculate the former charge for each atom in your molecule. And that's it for this video. I hope this video more or less helped you a bit in understanding former charge and plausible structure. Do give me a like and do subscribe to my channel for more videos. I'll see you in the next video. Thank you.